So up next, we've got one of the newest members of COMIT. So Richard is coming to speak to us about digital twins, but also bringing a true view perspective to the world. So over to you, Richard.
Thank you very much. It's great to see you all. 25 years of experience in AECO, and you're all saying, no, there's no way you can have done that. It doesn't look as if it's 25 years old. But yeah, 1996, I started my first business, and I was very interested in using mobile technology. And you're thinking, what mobile technology was around in 1996, right? So that was Palm Pilot. And in 1999, I was approached by the MD of a construction company based in Cardiff, and he said, I want to put mobile computers on the construction site. And that started a journey that led me into the AECO sector, and it's been a fantastic journey. In 2003, I actually joined COMIT. So whilst I'm the newest member as part of Twinview, I was there at day one as well, and it's a fantastic community, and it's great to be speaking to you all as well. So what I'm going to try to do today, I've got quite an ambitious, wrong way. Wrong way again. Wait, hang on, here we go. There we go. Right, okay, looking at the wrong one. I'm going to talk about digital twins. I'm an innovator. I innovated with mobile technology. All the conversations we had earlier on about how long it takes to change culture and adapt new technology. I love innovation. And I think at those early stages of innovation, a big part of that is helping the market, the audience, the people who are going to consume this innovation to understand what it is. And when we think about digital twins, I feel almost at the same stage as we were at the early stages of BIM. Everybody's got a view in terms of what it is. Everybody wants to be associated with it. I was at DCW last week, and almost every technology stand had some reference to digital twin on it, irrespective of the product that they were developing. So what I'm going to try to do today, and it's quite ambitious, is to give everybody in the room a bit of a digital twin 101. We were talking about sharing information earlier on. I'm going to try to share with you what I've learned over the last 6 months. So if you leave knowing a little bit more about digital twins, then I'll be really happy. Let's give it a go. Make sure I go the right way. So that's wrong way. Okay, down. So the definition of a digital twin, it's up there. I'll leave you read it. This has come from Wikipedia. Many other sources around there, but it's pretty consistent with the definition of a digital twin. The idea that you have a physical twin, a real-world object that's been created or is planned to be created, and you have a digital equivalent which is connected to it. And the connection is really important here. And used for the purposes of simulation, integration, testing, monitoring, or maintenance. Okay, what does that mean? And you always see these pictures of real objects and virtual objects. We've seen those a lot. You see them wherever you look up digital twins. So I'm going to try to depack this. I'm going to use something that probably everybody's quite familiar with, which is a bike. All right? We've all had a bike at some point in our life. So let's think about how we would create a digital twin of a bike and what it would mean, right? So physical twin, it's over there on the left-hand side. We've all seen one before. If we think about what is contained inside of that physical object? Well, you've got materials, you've got a frame size, you've got gear ratios, you've got a tire specification. I call this kind of static information, okay? It's not changing minute by minute, hour by hour. It's relatively static. It doesn't change. If you take that information by measuring it or designing it, you can create a digital model. Now, this should be pretty familiar to most of you in the room here, okay? We create digital models of assets and facilities using BIM every single day. A digital model is not connected to this real object at all. It's completely detached. It's created manually by an architect somewhere else. It's designed to create a model that has the same kind of attributes, qualities, and specifications as the physical asset, but it's not connected. And in BIM, we start to do a little bit more with that model. We embed metadata into it, so the model may contain a brake lever. That brake lever may have a part number, and that part number may be embedded into that particular component of that model. We're all familiar with digital models. We use them every day. It's the world of BIM. How do we get closer to a digital twin? And my colleague just here was talking yesterday about shadows and about digital twins. If we were to take some sensors, things that can measure things in real time, we could connect them to that bike. And it happens today. So let's imagine we wanted to understand the rider weight. How heavy is the person on it? We could put a load cell on the seat. That load cell could measure the weight of that rider. The tire pressure, we have them in our cars all the time, tire pressure monitors, right? We can put them inside of the tire, we can understand tire pressure, the selected gear, maybe the pedal speed, maybe the road speed, maybe the incline. All of this stuff can be done. You can do this, and of course you need some communication to be able to send that information back to what is generally known as a digital shadow. Now, digital shadow, digital twin, digital model, maybe getting a little bit confusing. A digital shadow is generally described as having real-world dynamic information about that physical object, but no way to send information back to that physical twin or to make it change its properties or do something different. What kind of properties would you want to change on a bike based upon that information that you're receiving there? Well, maybe you want to brake, right? Maybe you might have a proximity sensor on the front of your bike there, and it understands that you're traveling pretty quick, and you're about to hit a tree, and you might want to brake. You might want to stop that bike, or you might want to automatically change the gears. All right. So when you get this feedback from this digital shadow back to the physical twin to be able to do something with it, to change what it's doing or change how it's behaving, that's when you get a digital twin. So we talked about a digital model, which is just a model created like we have in BIM. We talked about a digital shadow, which has information about that physical object in real time, time series data, things that change pretty frequently. And we have a digital twin where we can actually control that device as well, that object as well. Now, digital twins are new in construction, but they aren't new in other industries. And we talk about other industries quite a lot. You've probably all seen this digital index that showed AEC construction down there with sort of, agriculture. And right up the top here, you've got manufacturing and automotive and finance who have gone through this digital transformation. When I started work in the AEC sector, it was just off the back of the Egan report, called construction AECO the sleeping giant, right? I think we are primed to change, and we're going to change by learning from other industries. And this has been spoken about already by other presenters over the last couple of days. Oh, gone the wrong way again. Okay. I'm going the wrong way again. All right, here we go. So, digital twins in automotive, right? So we've all seen a perfect example of a digital twin. It's a Tesla. A Tesla is, in my mind, the best example of a real-world digital twin that you could begin to imagine. The static data is all the information about the model number, the bill of materials, the part number, specification, supply chain provenance. Automotive have been doing this for decades. They can do manufacturer recalls based upon one component that's out of specification because they have that level of detail. This idea that we have in terms of golden thread and digital continuity that we're struggling to deal with, automotive have dealt with that decades ago. In terms of the dynamic data, within a Tesla, there are 20 plus sensors that are responsible for understanding environment and space, what's around it, 70 plus sensors looking at vehicle management, and 10 plus sensors looking at driver interaction. And it's a true digital twin because it can make an intervention for you. I don't know if you've seen these videos sometimes, Tesla driving down the road, somebody changes lane, and suddenly the Tesla sort of just moves out the way, all right, without any kind of intervention by the driver. We have full self-drive now. We have enhanced security. We have over-the-air updates of this vehicle that you see, every one of us, every single day. Wrong way again. Digital twins in aerospace have been around for decades and decades. It's probably one of the reasons why air travel is the safest form of transport on the planet. Again, model numbers, bills of material, parts number, specifications, static information, things that don't change very often. But the amount of dynamic data that's being collected in real time during flight in an airplane is unbelievable. 25,000 plus sensors in a Boeing Dreamliner. Most of them on the wings. I actually visited a plant in Flint once where they were making the wings for the Airbus, and they were using our mobile tools, actually, to record how sensors were being placed into the wings. As I said, safest form of transport, simulation and testing, emergency management, and over 2 decades of very safe travel within the aerospace sector. A human digital twin? We are probably all human digital twins. If you're carrying around an iPhone or an Android phone, the amount of information that you're giving to those companies about anonymously, because they don't know who you are, but they definitely know what phone you've got in your pocket, about where you are, what you browse, when you wake up. Maybe, I don't know if they check, if they look at your alarm statuses and so on. Maybe they do. But smartwatches and Fitbits that are measuring your heart rate, that are measuring other aspects of your physical being, are essentially a digital twin. Now, can it really be called a digital twin? Is it intervening? Is it feeding anything back to you to make you do things differently? Perhaps not. Maybe more of a digital shadow in that case, perhaps. Twin, shadow, who knows? But the term twin and shadow, just for this piece, is within our space, within AECO, is used kind of interoperably. Digital twin, digital shadow, they're used interoperably. Let's look now specifically, bring all of that learning back to AECO and what it means for the AECO space. I'm going to do this again, aren't I? Yeah, I am, right. Okay, digital twins and AECO. So this whole idea that we combine static data and we combine dynamic data to understand what's really going on inside of this building is what digital twins are all about within AECO for me. And the static data is the world that we all know. We have a BIM. It contains the physical geometry, the specifications, the attributes of that facility or that building. We have a load of documents, drawings, specifications. We have an asset information register or asset information requirements, which transform into an asset information management list. We have ways to capture changes to the building using scanning, point cloud acquisition that people have talked about. We have O&M manuals about how do you maintain these assets inside of these buildings and make them work properly. All of this stuff is static information in my world. Okay? At the point of handover, it's unlikely to change. Now, the building will change. It may have an extension. I understand that. But minute by minute, hour by hour, that stuff is relatively frozen at the point of handover. The dynamic information is connected is about the real operational performance, what's really going on inside of that building. And we can do that in a number of ways. We can connect into the building management system, which is usually the heart of all of the operational technology that you'll see inside of a building. It connects to all the high energy consuming components, heat, lighting, ventilation, and so on. And very often when BMSs are installed, they're installed with a very large number of sensors, or endpoints as we call them, by the MEP contractor, and it feeds back to the BMS. And facilities managers are expected to be able to interpret and use this information. It doesn't happen very effectively at the moment. IoT, we can retrofit sensors, and I'll talk a little bit about that in a moment. Understanding how energy is being consumed, distributed, stored, or fed back into the grid. People. We don't build buildings to be empty, static shells. They get filled with people. They move around, they do things, they work, they operate, they perform their purpose. Where are they, what they're doing, how, where they're hanging around, where there are large concentrations of people. It's really important. And also environment, and many, many, many other dynamic characteristics that you could work with or consider. This is what we consider to be a digital twin, or what I consider to be a digital twin within the construction space. Then again. Now let's think about this for a moment. This is the kind of the typical REBA stages that, again, you might all be familiar with. But I think what we have down on the bottom here is really interesting. If you take a facility or a building, and these are kind of rule of thumbs, okay? Might take a year to design, 2 years to build, and 25 years of operation, right? Just take a hospital or a school. And in terms of the cost of that over that period of time, 3% of that cost might be in design, 17% of that cost is typically in construction, and 80% of that cost is in operation. So when we build buildings, the most significant amount of time, clearly, obviously, is during operation. But when you think about the tools that go into delivering digital information and BIM, we seem to stop at handover. Everything that we do, and most of the tools that we have available to us right now, are fantastic for managing information, coordinating information, delivering it to the right people, approvals, and so on. But we get a handover, and it kind of stops, right? How do we maintain that digital continuity? Because it's important, because things like the Safety Act and the Golden Thread require us to do that now. How do we maintain that digital continuity into operation? How do we maximize the value of BIM and all of the effort and time and money that we've put into understanding this digital information and use it in the operational environment? Because that's why we build these buildings, right? We build a school because we want it to be a great place to learn. We build a hospital because we want it to be a great place to get better. You know, this is the end goal here. We don't build buildings and hand them over to be empty, unoccupied shells. We build them to operate. And what are the drivers that we are looking to? I'm going to do this again. What are the drivers here? This is quite interesting, I think. Digital continuity and digital compliance. You can't really read what's up there, but it's a reflection of BIM between 2011 and 2020. And essentially, it's saying in 2011, BIM wasn't used an awful lot. 2020, it's used everywhere. BIM is here to stay. This idea of a data-centric industry is here to stay. We're still in its infancy, I think, in some ways, but it's not going away. It's here. It's not going to change. We had the tragedy at Grenville, which led to the Building Safety Act. And you know, when you think about that, you know, how often do we consume anything where we don't really know what it is that we're consuming? You know, you don't eat things. You don't eat something unless you know what's in it. You know, you tend to buy things because you know what they're made of. But we live in things, and we did often have no idea what they were made of, or what risks they presented to us. And you know, the Safety Act and the Golden Thread and digital continuity is going to be an important part in that. We've talked about net zero decarbonisation a lot over the last 2 days. Understanding how energy is consumed within a building is quite a vague art at the moment. You know, it's not really well understood. It's well documented that it's not really well understood, and it's the biggest contributor to carbon emissions from that facility, right? Gas and energy consumptions. This idea that we hand over a physical and digital asset, that's been sort of in play for many, many years. But what digital asset do we hand over right now? Minimum viable digital asset to hand over is a, COBE spreadsheet? Yeah, maybe. I've seen it handed over. You know, it's a list, right? It's one step away from paper, I believe. And why should we have a viable digital asset to hand over? Because customers, smart customers, are now making it a contractual requirement that instead of just building a building and walking away or looking after the 1 year latent defect period, they now require the contractor to validate operational performance. So the DFE in England write this into the contractual requirements, right? You need to validate operational performance. Now, how do you do that unless you're measuring something? Unless you have the capability to measure and understand the performance of that building. So this whole idea of digital twins is going to work. And sustainability and carbon footprint, net zero, you know, what gets measured gets managed. And I think this is, you know, something that's really fascinating in terms of the whole digital twin space. Done it again. So where are you on the digital journey and digital continuity? And I think, again, this is really interesting and a certain degree of aspiration towards the right-hand side of the road here. But right now, we are beginning to sort of create this idea that we need to define data early stage before we even cut the ground. This idea of AIRs, asset information requirements, exchange information requirements that are published and issued and created at the very earliest stage of the project. During the construction, the design and construction, this asset information requirement essentially becomes an asset information model because these things become real, they become installed, they become part of the system, and they become, you know, real entities. Digital handover. You want to hand over perhaps more than a COBie spreadsheet, right? I think let's hand over that full BIM capability with operational readiness. Let's aspire to do that, because once you get into operations, you've got your standard kind of facilities management capabilities. Tell somebody to go somewhere and do something, make sure it's done, But with a digital twin and real dynamic measurements, you've got this ability to begin to think about how can we automate the building. How can we get the building to be somewhat sort of self-aware and to a state of sort of continual smart commissioning, just continually looking after itself, and then ultimately building optimization. Understanding the moving parts and the dynamics of a building facility, and then applying some really smart technology to that can start to give you some real interesting insights in terms of where can you save wasteful energy without having any kind of impact on the performance or the comfort of the people that are within that facility. I think digital twins are a catalyst for change in this industry. And I think it's going to be an exciting ride over the next 5 to 10 years just to see how that happens. And I think it's going to be driven by the things that we spoke about earlier on, particularly net zero, particularly the rise, inevitable rise and power of AI. My personal view is that in the next 5 to 10 years, AI is going to eat digital construction. Now, I'm not going to tell you how or why, because I really don't know. But we've spent 20 years focusing on data, and we are now at a situation where we, by default, hand over a relatively well-defined, well-labeled set of data, and AI is going to eat that. It's going to eat it up, I think. Done it again. Okay. Legacy buildings versus modern buildings. So it's quite interesting. The building stock in the UK at the moment, 12% of it was built in the last 10 years. Relatively modern buildings, relatively modern technology. They might have an energy model. They will definitely have a BMS. They'll probably have a BIM. They might not have a digital twin, but they've got pretty smart technology, a lot of things that you can tap into. Legacy buildings, and I'll call those more than 10 years old, 82% of building stock in the UK, non-domestic building stock. The interesting thing here, the interesting challenge is, in terms of energy optimization and net zero, legacy buildings have by far the most to gain by being more efficient, but they don't have any, or may not have any digital footprint, and they probably haven't got any smart technology within them. So how do we deal with this problem? How do we deal with I won't use the term. How do we deal with legacy buildings and make them more efficient? I'm going to do, yay. Okay. So just a little bit about kind of sensors and sensing technology that I want to share with you. And something I've learned just recently, well, over the last kind of 6 to 12 months or so. Sensing technology and digital twins is really exciting for me because the scope of application and performance improvement and creativity is massive. It's based upon what you measure. LoRaWAN is a technology that's almost exclusively used for retrofitting sensors inside of existing buildings. Why is it used and why is it important and why does it work? Well, LoRaWAN sensors, which you see on the left-hand side there, which are in abundance from manufacturers like Siemens and Bosch, for measuring anything you can think of, basically, are generally very small battery-powered devices with very long battery life, very low power, so they can often operate for 4 to 5 years. They use radio frequency communication to communicate with a LoRaWAN gateway, which means that they've got very long range. LoRa actually means long range. So if anybody wants to LoRaWAN, it's LO is long, RA is range. Which means that you can get great penetration within existing buildings, providing that gateway has some kind of internet access, and they might use a kind of aggregated 5G router. You can deploy sensors like this into a legacy building without compromising the security of that building whatsoever. You're not talking about connecting into the networks. You're essentially overlaying a sensing capability that doesn't compromise the building in any way. And that's very, very powerful and very, very useful because, there's no threat. There's no kind of, compromising the security of that building. The idea that you move, you connect this LoRaWAN gateway out to the internet and to the cloud, and that applications like Twinview connect to that data, that sensor data via the cloud. I want to just explain just something about that. When you connect to the data in these sensors via a digital twin or any kind of sensing technology that's using the internet, it doesn't connect directly to the sensors. Okay, what they call here this sort of internet-based MQTT broker is almost like an abstraction layer. It's this idea that there's always going to be some data there for you, irrespective of what the sensor below it is actually doing, because the sensor is working in a completely different domain, and you need to know that you have availability. I got 30 seconds. So why are we going to do this? What is the ultimate impact of all of this? It's huge. This is a report from Dubai Silicon Oasis. They switched to an AI-enabled building management system, deployed a lot of sensors as part of that in Dubai. You can read this. I can send you the links. The quoted savings here, all right? Almost £250,000 a month in savings. £250,000 a month across that facility. Reducing energy consumption by 36% without impacting the performance or operation of the building by being more smart about how you use energy based upon what is going on in that building. And reducing facilities management staff from 110 to 5. Now, I really do hope that those 105 people are being deployed valuably in other parts of the business there. And this is what we were talking earlier on about disruptive technology and what do we do with these people. But the future for digital twins is compelling. And I think it's going to be the catalyst driven by energy optimization primarily and net zero that's going to see a significant change coupled with AI over the next 5 to 10 years. It's an exciting place to be. And if you want to understand any more about this, please do contact me. We've got, this is real. We've got this kind of capability in real buildings in the UK in operation today, where their owner-operators can look at a dashboard and see how much carbon emissions we've created from gas or electricity today. It's real. It's there. It needs to be used. We're in early adoption territory, but it's a very exciting space to be in. Thank you very much.